The science behind crypto, why it's more than just money. Cryptocurrency is far more than just a new way to conduct financial transactions. It operates on fundamental principles of physics, mathematics, and even universal laws. It challenges our traditional concepts of money, trust, and authority. Driven by lines of code and scientific principles, cryptocurrency exists independently of banks and governments. Understanding the science behind crypto can fundamentally change your perception of money, energy, and technology itself. It's a paradigm shift. Traditional currencies like the dollar or euro are backed by the promise of a government. Cryptocurrency, on the other hand, is secured by the unyielding power mathematics. This is a crucial distinction. Bitcoin, for example, relies heavily on the SHA-256 cryptographic hash function. Interestingly, this function was originally developed by the National Security Agency, or NSA. It's a testament to the power of cryptography. SHA-256 takes any input, regardless of size, and converts it into a unique 64-character string. This string is often referred to as a hash. Even a tiny change in the original input will result in a drastically different output hash. This seemingly simple function is the backbone that makes the blockchain possible. Transactions and blocks of data are inextricably linked and locked together using these cryptographic hashes. It's like a digital fingerprint. The beauty of SHA-256 lies in its nature as a one-way function. It's computationally infeasible to reverse engineer the original input from the output hash. This makes it incredibly secure. In essence, Bitcoin replaces the need to trust institutions with the unwavering trust in mathematical certainty. This is a profound shift in how we think about security and verification. The math doesn't lie. Bitcoin mining is the process of adding new transaction records to Bitcoin's blockchain. This involves solving complex computational puzzles. Millions of computers around the world compete to be the first to solve these hash problems. The first miner to successfully solve the puzzle gets to add the next block of transactions to the chain. They are then rewarded with newly minted Bitcoin. This entire process is known as proof of work. Proof of work is inherently energy-intensive. The computational power required to solve these puzzles consumes a significant amount of electricity. In fact, Bitcoin mining consumes more electricity than many small countries. But this energy consumption isn't a flaw, it's a feature. Solving these complex puzzles is akin to creating order from chaos. It's like building a sandcastle on a beach constantly being battered by waves. Thermodynamics dictates that creating structure and order requires work. Entropy, the natural tendency towards disorder, constantly resists this effort. The energy cost of mining makes manipulation incredibly difficult. This high energy cost reinforces the integrity of the Bitcoin network. It makes it prohibitively expensive for any single entity to try and tamper with the blockchain. The energy expenditure is a security mechanism. Cryptocurrency networks are decentralized. This means there is no central authority controlling the system. There's no headquarters, no CEO, and no central clock dictating the pace of operations. In the case of Bitcoin, new blocks are created approximately every 10 minutes on average. This carefully calibrated timing allows for network synchronization and agreement across the globe. It's a distributed dance. This creates a decentralized timekeeping system. Nodes or computers on the network independently reach consensus using mathematical rules. They don't rely on a central time server. Imagine thousands of clocks around the world, all syncing with each other without a central master clock. This is the power of decentralized timekeeping. Consensus is achieved by following the immutable laws of mathematics and physics. Quantum computing represents a potential existential threat to many cryptocurrencies. Quantum computers, still in their early stages of development, possess immense computational power. This power could break existing cryptographic systems. Quantum algorithms, such as Shor's algorithm, are specifically designed to factor large numbers. This capability could compromise the public-private key systems that secure many cryptocurrencies. If these cryptographic systems are broken, coins could be stolen by malicious actors. They could essentially break the math that protects the network. This is a serious concern for the future of crypto. However, the crypto community is actively working on solutions. Post-quantum cryptography is a field dedicated to developing algorithms that are resistant to attacks from quantum computers. These new algorithms are being designed to withstand the immense computational power of quantum computers. It's a digital arms race between those who want to break the system and those who want to protect it. The stakes are high. Cryptocurrency is more than just a digital currency. It's a scientific revolution. It takes raw energy and transforms it into digital value. It uses the power of mathematics to build trust in a trustless environment. It treats time not as a rigid construct, but as a shared illusion agreed upon by a distributed network. And it's even preparing for a potential quantum apocalypse. In essence, crypto is a fascinating intersection of physics, mathematics, and cutting-edge technology. It's not just the future of finance, it's a glimpse into the future of how we organize and interact with the world around us. Follow and subscribe for more contents.